Hi friends, in this video, we solve this example. Convert the quadratic form Q into the normal form, or we can say the canonical form by using the orthogonal transformation x equal to py. So here this is your quadratic form Q equal to 2x1 square plus 2x2 square plus 2x3 square plus 2 times x1 x3. So here the working rule to convert the given quadratic form into the normal form is the following. So here first working rule to convert the given quadratic form Q into the normal form is that first write the given quadratic form in terms of matrix notation. So here matrix notation of the quadratic form is Q equal to x transpose A x. So here in this example Q is the quadratic form in three variable x1, x2, x3. So here you will get a square matrix A of order 3 cross 3. So here you will get matrix A of order 3 cross 3, which is a square matrix. Now the second working rule says that here after finding the matrix A, find the eigenvalues of this matrix A of order 3 cross 3, or you can say n cross n. Find eigenvalue of A, say lambda 1, lambda 2 and lambda 3. So here say lambda 1, lambda 2, lambda 3. So here first convert the given matrix, given quadratic form into the matrix notation of the quadratic form, that is x transpose Ax. After that find the eigenvalues of this matrix A. So that is, let's say A is a matrix of order 3 cross 3. So corresponding to that matrix, let's say lambda 1, lambda 2, lambda 3 are the eigenvalues of this matrix A. Now third step is find eigenvector corresponding to each eigenvalue. So after that find the eigenvector corresponding to the each eigenvalue lambda 1, lambda 2, lambda 3. Say x1, x2 and x3. So here corresponding to lambda 1, let's say x1, corresponding to lambda 2, let's say x3 is the eigenvector, and corresponding to lambda 3, x3 is the eigenvector. So fourth working rule is build model matrix P having normalized eigenvector. So this means that, so here from this third step you will get the eigenvector x1, eigenvector x2, eigenvector x3 corresponding to the eigenvalue lambda 3. So here this x1 is one column vector, this x2 is one column vector, and this x3 is again one column vector of order 3 row and 1 column. Now this model matrix P is the model matrix P having normalized eigenvector as its column. This means that the first column of your model matrix P is the first eigenvector, second column of your model matrix is the second eigenvector, and third column of your model matrix is the third eigenvector, that is your model matrix P. So here after that, so this is your model matrix P. So you find the diagonal matrix D by using P transpose A P. So here write D equal to P transpose A P. So from this fourth step you will get the model matrix P and take the P transpose and A P, you will get D equal to P transpose A P, where D is the diagonal matrix, where D is equal to diagonal matrix with diagonal entries are the eigenvalues of this matrix A, where lambda 1, lambda 2, lambda 3 are the eigenvalues of this matrix A. This is your fifth step. After that, here from step 1 Q equal to x transpose Ax, that is given information. Here use x equal to Py orthogonal transformation in Q equal to
x transpose Ax. So just put the value of x as py in this quadratic form. So here q equal to this is p y whole transpose A and this is p y. So here properties of the transpose AB transpose equal to B transpose AB. So here this is same as y transpose p transpose A and this is p and y. So from equation 5 D equal to P transpose AP. So here this is P transpose AP. Just write Y equal to. So here write Y transpose and this is as P transpose AP, write as D. This is equal to D. This is your Q equal to Y transpose DY is the normal form of your quadratic form Q, or you can say the canonical form of your quadratic form. So with the help of this normal form we can find the index, signature and rank of your quadratic form Q. So here how to convert the given quadratic form Q into this form Q equal to Y transpose dy. This is the normal form or canonical form of the quadratic form Q. So here I will solve this example one by one. First I will write the matrix notation of the quadratic form. So after that I will find the eigenvalue. After that I will find the eigenvector, and then I will build the model matrix P. So here this is my quadratic form. My first step is to write the matrix notation of the quadratic form Q. So here step 1 matrix notation. So here this is my answer. In answer my step 1 is matrix notation of Q is Q equal to X transpose A and X. So here this X is the column vector of order 3 cross 1. Therefore this X is the row vector of order 1 cross 3. So here I am writing this is equal to here x1, x2 and this is x3. Now so this is my matrix A. Here this is my matrix A and this is the column vector x1, x2 and x3. Now how to write this matrix A with the help of in 3 coefficient, in 3 variable x1, x2, x3. So here first row of this matrix is here R1 is coefficient of x1 square, coefficient of x1, x2 by 2, coefficient of here this matrix is here. I don't have space, that's why here I am writing. After that I will here coefficient of x1, x3 by 2. So here second row is coefficient of x1, x2 by 2. So a1 is same as a21. So third row is coefficient of x2 square, coefficient of x2, x3 by 2. Here coefficient of this is x31, coefficient of x1, x3 by 2. This is coefficient of x2, x3 by 2. This is coefficient of x3 square. So here just write here this matrix corresponding to this. Coefficient of x1 square is 2, coefficient of x1, x2 by 2. Here x1, x2 is not there, so here write 0. Coefficient of x1, x3 is 2, 2 by 2 is here simply 1. Now come to the second row, coefficient of x1, x2. So here a12 entry is same as a21 entry, so right here this is same as 0. Now here this diagonal, now coefficient of x2 square, this is 2. Now this is coefficient of x2, x3 by 2, so coefficient of x2, x3 is 0 here, that's why I write here 0. Now coefficient of x1, x3, so here this is 1, so here a13 is same as a31. Now coefficient of x2, x3, here this is 0, a23 is same as a32, here 0. Now this is coefficient of x3 square, this is again 2. So this is my matrix representation of the quadratic form Q. So here from here step 1 achieved. Now so this is my matrix A. Now this is the square matrix A of order 3 cross 3. Now I want to find the eigenvalue of this matrix A. So here step 2, this is my matrix A. So here this is my matrix A. Step 2 is find eigenvalues of A equal to, here I want to write this matrix again here, 2 0 1 0 2 0 1 0 2 by characteristic equation. By solving this characteristic equation, A minus lambda I equal to 0. So here instead of that, so this is a square matrix of order 3 cross 3. I will write the characteristic equation in terms of lambda by using here lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0. So here s1 is the trace. Here s1 equal to trace of my given matrix, which is equal to 2 plus 2 plus 2, that is 6, and s2 equal to m11 plus m22 plus m33, which is equal to, now I want to find the minor of this element m11. So 4 minus 0, that is here determinant of 2002. Now after that I want to find the minor of this element. Here hide the second row and second column, 2 1 1 2. This is 2 1 1 2. Now again I want to find the minor of this element. So 2 0 0 2, 2 0 0 and 2. So this is equal to here 4 minus 0 plus 4 minus 1 plus 4 minus 0, which is equal to 4 plus 3 plus 4, which is equal to 8 plus 4 plus 4, 8 plus 3, that is 11. So this is my S2. So here I got S2. Now just find S3 is the determinant of your given matrix here. Now find S3 equal to determinant of your given matrix A. So here determinant of this matrix here 2 into here 4 minus 0 minus 0 times anything is 0, that's why here I am not writing, plus 1 times here 0 minus 2, 0 minus this is 2, which is equal to 2 times this is 4, this is 0, plus 1 times this is minus 2, this is equal to 8 minus 2, which is equal to 6. This is my determinant. So here put this value S1, S2 and S3 in this equation 1. Therefore equation 1 becomes lambda cube minus S1 lambda. Here the value of S1 is 6 lambda square plus S2. So plus S2, the value of S2 is 11 lambda minus S3, the value of S3 is 6, which is equal to 0. Now we have to find the root of this equation in terms of lambda. So here use the hit and trial method. After that use the synthetic division. So here first try the possible roots. The possible rational root of this equation is divisors of this here. Divisors of possible roots are possible roots are here. Divisors of this one, divisors of this leading element are plus minus 1, and divisors of this constant are plus minus 1, plus minus 2, plus minus 3 and plus minus 6. These are the possible roots here. Plus minus 1, plus minus 2, plus minus 3, plus minus 6 are the possible roots of this equation. Let's say this is the 2. So here just try with hit and trial. Let's say I will try with 1. So here 1 cube is 1, minus 6 into 1 square is 1, plus 11 into 1 is 1, minus 6. Now just observe one thing. So this is plus 11 plus 1 plus 12, this is minus 6 plus 3 plus minus 6 plus 6, that is minus 12. This is equal to 0. Therefore 1 is the one root. So here if 1 is the one root, we can find the other root. Here if 1 is the one root, so we can find the other roots. If 1 is the root, we can find the other roots by using synthetic division. So here I will write by synthetic division. Here 1 times here this is 1 minus 6 11, this is minus 6. So here write this one as it is here, multiply this one with this, here subtract this, minus 6 plus 5, this becomes here minus 5, minus 5 into this 1, this is minus 5, again subtract, so this becomes plus 6, here multiply, write 1 as it is, multiply 1 with this,
After that, write 1 here. So add these two things here. Minus 6 plus 1 becomes minus 5. So minus 5 into 1, minus 5. Write minus 5. So let's subtract 11 minus. Add these two things. 11 minus 5, that is plus 6. Then multiply this 6 with here. Here this minus 6, this is plus 6 becomes 0. Therefore, here the required equation is lambda minus 1. Here this lambda minus 1, and from here to here I am writing here lambda square minus 5 lambda plus 6 equal to 0. So here from here lambda minus 1, just factorize this. This is lambda square minus here 2 into 3 are 6. Here 2 lambda minus 3 lambda 2 lambda minus 3 lambda plus 6 equal to 0. So this is lambda minus 1. This one is, from here take lambda common, lambda minus 2. From here take again minus 2 common, again lambda minus. From here take minus 3, again lambda minus 2 equal to 0. Therefore lambda minus 1. From here lambda minus 2. From here lambda minus 3 equal to 0. Therefore lambda equal to 1 comma 2 comma 3 are the root of this equation. Therefore lambda equal to 1 comma 2 comma 3 are the eigenvalues of this matrix A. Therefore lambda equal to 1 comma 2 comma 3 are the eigenvalues of A, given matrix A of order 3 cross 3. So here now second step is also achieved. So first one, matrix notation of the quadratic form. So this is the matrix notation of the quadratic form. From this quadratic matrix notation, I get matrix A. After that, second step is find the eigenvalues of this matrix A by using characteristics equation A minus lambda equal to 0. So here the same characteristics equation in terms of lambda here I am writing. S1 is my trace, S2 is the sum of the principal minus, and S3 is the determinant. Just as put this value S1, S2, S3 in this equation. I got this equation. After that I use by eta trial. If one is the one root, then remaining root I will find with the help of this synthetic division. So I got the root as lambda equal to 1, 2, 3. So this root are the eigenvalues of your given matrix A. So here up to now we have find first is matrix notation, second is eigenvalues of your given matrix. Now third step we have to find the eigenvector corresponding to each eigenvalue. Now we have to find x1, eigenvector x1 corresponding to this lambda 1, eigenvector x2 corresponding to this lambda 2, eigenvector x3 corresponding to this lambda 3 equal to 3. Now I want to find eigenvector x1, x2, x3. Here I don't have space, that's why again I will so please pause, and if you want to write now. Here I want this matrix later, that's why here I will keep this matrix as it is. So here I want to multiply D equal to P transpose, that's at that time I need this matrix. So here I will write this matrix here over here. So let's say this is my matrix here. Now let's say E equal to, this is the matrix notation of my let's say this is the matrix obtained from this quadratic form Q. Now step 3 here, step 3, find eigenvector xi by A minus by solving determinant of A minus lambda I into I into xi equal to 0. So here I want to find the eigenvector xi by solving this equation A minus lambda I into xi equal to 0. So here I want to find x1 by using A minus lambda 1 into x1 equal to 0. I want to find x2 by using this A minus lambda 2 into I is the identity matrix, into x2 equal to 0. In the same way, A minus lambda 3 into identity matrix I of order 3 cross 3 into x3 equal to 0. So here I will solve one by one. Now for lambda
1, let's say lambda 1 equal to 1. So for lambda 1 equal to 1, I want to find x1. Solve a minus lambda 1 is 1. Here a minus, let's say again I will write a minus lambda 1 into I into x1 equal to 0. Now I will put the value up here. Therefore a minus lambda 1 is 1 I into x1 which is equal to 0. Now A is the given matrix and A is the given matrix of order 3 cross 3. Here I will take I is the identity matrix of order 3 cross 3. So this A minus I is the matrix subtraction between A and I. So here I will write the resultant matrix directly, A minus I. So here 2 minus first entry of identity matrix is 1. 2 minus 1 is 1. 1. Remaining entry 0, 1 as it is. Here 0, 0, 1, 0. Here 1, 0. This is minus 1, 1, 0. This is again 1 into. Here I will write this as here x1, x2, and this is x3. Now which is equal to, here I will write here, let's say 0, 0, 0. Here left hand side is matrix, right hand side must be matrix of order same. Now I want to find by solving this system of equation. Let's say this is nothing but the system of equation Ax equal to b. So this is the homogeneous system of equation in 3 unknown x1, x2, x3. I want to find the value of x1, x2, x3 by solving this equation. First of all, I will convert this matrix into the echelon form so that it is easy to calculate the value of x1, x2, x3. Now convert this matrix A. So this is my Ax equal to b. Here Ax equal to b. So here A is my this matrix, x is the column vector, and b is the vector of constant 0, 0, 0. Now I want to convert this matrix into the echelon form. Now here I want to convert the matrix into echelon form. Here I want to convert this matrix into the echelon form. So how to convert is the following. Now how to convert? So here this is my matrix. Here first of all I will write this matrix. Here I want to convert this matrix 1, 0, 1, 0, 1, 0. Here 1, 0, 1. Now I want to convert this matrix into the echelon form. So here I want to make this entry as 0. So here I will apply operation as R3 changes to R3 minus simply R1. So here after that, here I get 1, 0, 1. Second row it is 0, 1, 0. Here 1 minus 1 is 0. From here 0 minus 0 is 0. Here 1 minus 1 is, this is simply 0. Now this is the echelon form of my matrix A. Just wait. So now this is the echelon form of my matrix A. Now you can observe one thing. So here this is the echelon form. 0 row of this matrix here after the below non-zero row. Leading element of R2 occurs right to the leading element of R1. But here rank of this matrix is, here rank of this matrix A is equal to 2 and number of unknowns are 3. So here if rank of A that is equal to 2 which is less than number of unknowns that is 3. So here 3 parameters are, therefore 3 parameter equal to n minus r. Here n is 3 and r is 2. N minus r, this is 3 minus 2 equal to 1. So this means that we have to assign one free parameter either to x1, x2 or x3. But you can observe one thing. So here this is the matrix which is corresponding to this matrix. So here I converted this matrix into this echelon form. This means that this matrix is similar to this. But here corresponding to x1, let's say here this is the x1. Corresponding to x1 I have pivot in my first column. Corresponding to x2 I have pivot in my third column, second column. But corresponding to x3 I don't have pivot here. That's why here I am assigning this x3 as the t. Therefore, so by back substitution again, by back substitution, right? Therefore here 1, 0, 1, 0, 1, 0, 0, 0, 0 into here x1, x2, x3 which is equal to again 0, 0, 0. So here, therefore, again by back substitution here, x1 plus x3 equal to 0. From row 2, here x2 equal to 0. Now if x2 equal to 0, and here we have to assign one 3 parameter and x3 as the 3 parameter t. If x3 is the t and put so here from here x1 plus x3 equal to 0, from here x2 equal to 0, from here I am assigning x3 as t. So here I am assigning x3 as t. So just put the value of x3 in this equation. Therefore x1 equal to, that is minus t. So x1 equal to minus t. So just therefore I got the first eigenvector. So now here I got first eigenvector as, therefore here I will write here x equal to, here x1, x2 and x3 equal to, therefore x1 is minus t, x2 is 0 and x3 is t, which is equal to t times here minus 1, 0 and this is 1. So this is equal to t times x1. This is minus 1, 0, 1 is the eigenvector corresponding to the eigenvalue lambda 1 equal to 1. This is my eigenvector minus 1, 0, 1 corresponding to the eigenvalue lambda 1 equal to 1. Now in the same way, I want to find the eigenvector x2 and x3 corresponding to 2 and 3 respectively. How to find is the following. Now, so here, now solve for lambda 1, I solve this a minus lambda 1 into I into x1 equal to 0. Now I want to find solve for lambda 2 and lambda 3. So here I will again, I don't have space. Here I will write the eigenvector. So here I will write the given information. Sorry, x1 equal to here t times here minus 1, 0, 1. So just now I found x1. So this is my matrix. Now, so here now for lambda 2 equal to 2, solve a minus lambda 2 into I into x2 equal to 0. Now therefore lambda 2 equal to 2, just put this value here, a minus lambda 2 is 2 into I into x2 equal to 0. Now this is a matrix and this is 2 times I matrix. So here write just directly a minus 2I matrix. So here 2 minus 2 times 1, this is 0. Here 0, 1 as it is 0 and 1. Now 0, 0, 0, this is 0, 0, 0. Now this is 1, 0, here 1, 0 and this is 0. Now this is a minus 2 times I matrix. And here this is x2, that is x1, x2 and x3. Now in the same way as before, I want to convert this matrix into the echelon form. So here I want to convert this matrix into the echelon form. So here now in this case this matrix is not into the echelon form. So here 0 row occurs above the below row. Here convert this matrix. Here I want to convert this matrix into the echelon form. Let's say convert the matrix into echelon form. So here now here I want to, here this is my matrix. First I will write 0, 0, 1, 0, 0, 0, 1, 0, 0. Now here I will apply elementary operation as here R 1 and 3. I will interchange my first row and second row. So here I got the matrix here 1, 0, 0. Second row as it is 0, 0, 0. This is 0, 0 and 1. Now here I want to apply R2 and R3. Here I want to swap my R2, 3. So here I got the matrix as 1, 0, 0. This is 0, 0, 1, 0, 0, 0. Now, so this is the echelon form of my matrix. So here, and rank of this matrix is 2. So here, Now this is the echelon form. Here zero row of this matrix occur below the non-zero row. This is the leading element of R2 occurs right to the leading element of R1, and rank of this matrix is 2. Therefore, just count rank of this matrix equal to 2 and number of columns are 3. Therefore, 3 parameter equal to n minus r, that is 3 minus 2 is equal to 1. Here, so here I will write this matrix here corresponding to, let's say this is my matrix 1 0 0 0 1 0 0 1 0 0 0. Corresponding to x1, I have pivot in my first column. Here pivot of this row 1 R1 occurs in the first column. Pivot of R2 row R2 occurs in the third column. So this is pivot is corresponding to x3. But corresponding to here, but in this matrix I don't have pivot in the second column. That's why x2 is the free parameter. Here therefore I use the back substitution. Here first I will write the given matrix. Here 1 0 0 0 0 1 and 0 0 0. This is the given matrix. Now here you can observe one thing corresponding to this. So let's say this is my x1, x2, x3. Let's say this is my x1, this is my x2. Let's say this is my x3. Here pivot of row R1 occurs in the first column. That's why this is aligned with first column. This x2 aligned with the second pivot, means pivot in the second column. But here pivot of row R2 occurs in the third column. That's why here this is the free parameter. And the pivot here, this is x3. Pivot of here this x3 is aligned with the pivot of this which is occur in my third column. Therefore, use the back substitution here. Therefore, this is equal to this x1, x2 and x3, which is equal to again 0, 0 and 0. Now use the back substitution. So here corresponding to row R1, this is x1 equal to 0. Corresponding to this is x3 equal to 0, and assign x2 as t. Therefore, the eigenvector x2 equal to here x1, x2 and x3, which is equal to here x1 is 0, x2 is t and x3 is again 0. Therefore, t equal to here 0 1 0. This is equal to t times x2. This is the eigenvector corresponding to the eigenvalue lambda 2 equal to 2. Here I will write x2 as t times here 0 1 0. This is my eigenvector x2 corresponding to the eigenvalue lambda 2 equal to 3. In the same way, I want to find the eigenvector corresponding to lambda 3 equal to 3. Now, please, I hope all of you read that. I don't have space. I want to write over here itself. Now for lambda 3 equal to 3, solve this equation a minus lambda 3 into I into x3, which is equal to 0. So here put lambda 3 equal to 3. Therefore, a minus 3 times I into x3, which is equal to 0. Now A is this given matrix 3I. Here the matrix with multiplication of 3. Now just subtraction of these two matrices. Here I will write A minus 3I matrix. Here 2 minus 3, that is minus 1. Here 0 and 1 entry as it is. Here this is 0. 2 minus 3 is minus 1. This is 0. Here 1 0 1 0, and this is 2 minus 3 is, this is again minus 1 into here x1 x2 and this is x3, and into here 0 0 0. Now I want to convert again this matrix into the echelon form as usual. Here, so here convert this matrix. Here convert the matrix into echelon form. I want to convert this matrix here. First I will write this matrix here. Minus 1 0 1 0 minus 1. Let's say this is 0 1 0 minus 1. Now I want to apply the elementary operation over this matrix so that this matrix is converted into the echelon form. So here I will multiply my first row by -1. Here multiply -1 to row R1. Again, so here I will multiply second row. Here I will multiply first row, second row, and third row by -1. This is R1, -1 into R2, and this is -1 into R3. So here after this elementary operation, I get this matrix as here 1 0. This is -1. Here this is 0 1 0. This is -1 0, and this is 1. Now here I want to make this element as 0. Here apply elementary operation as R3 changes to R3 plus, let's say, R1. So here -1 plus 1 becomes 0. So here I got the resultant matrix as, here first row as it is 1 0 -1, second row as it is 0 1 0, third row -1 plus 1 0, 0 plus 0 0, here 1, this is 0. Now this is the matrix which is in the echelon form, and rank of this matrix is 2 and number of unknowns are 3. So I have to assign one 3 parameter. So here therefore rank of A equal to 2, which is less than 3. Therefore parameter equal to 3 minus 2, which is equal to 1. Therefore again by back substitution, therefore here 1 0 -1 0 1 0 0 0 0 into here this is x1, this is x2, and this is x3, which is equal to 0 0 0. Now here observe one thing. Corresponding to x1 I have a pivot in my first column, corresponding to x2 I have a pivot in my second column, but x3 I don't have pivot in my third column. So here I am assigning x3 as t. So here assign x3 as t. So I will write by back substitution. So this is equal to x1 minus x3 equal to 0. From here here I got x2 equal to 0, and assign x3 as t. Just put x3 value here. This implies that x1 equal to x3, that is equal to t. Therefore x3 as I got x1, x2, and x3, which is equal to, just put the value of x1 is here t, the value of x2 0, x3 is t. Therefore t equal to 1 0 1. This is equal to t times x3. This is the eigenvector corresponding to the eigenvalue lambda 3 equal to 3. So here I will write, so this is my A. Now here I want to write x3 equal to, here I want to write x3 equal to, here t times here 1 0 and 1. So here till now we got matrix notation, eigenvalue and eigenvector corresponding to each eigenvalue of the given matrix. Eigenvector corresponding to the each eigenvalue, and eigenvalues here lambda 1, lambda 2, lambda 3 are the eigenvalues of this matrix P. So now I want to form the model matrix P. So here first of all, second thing, I have to check whether my eigenvector x1, x2, x3 are normalized or not. So here when we say that the given vector x1, x2, x3 is normalized or not, just check the length of x1. Here length of x1 is under root -1 square is 1 plus 0 plus 1 2. So here length of x1 is not 1. This means that x1 is not normalized eigenvector. First I will show here. So here just observe one thing. So now we have to form the model matrix P having first column is the first eigenvector, second column is the second eigenvector, and third column is the third eigenvector. But that first column should be normalized, second column should be normalized, and third column should be normalized. What do you mean by x1, x2 and x3 is normalized? This means that length of x1 should be 1, length of x2 should be 1, and length of x3 should be 1. But here you can observe one thing, length of x1, that is norm of x1, which is equal to here -1 square plus 0 square plus 1 square, which is equal to here 1 plus 0 plus 1 which is equal to root 2.
Here norm of x1 is the length is never negative, that's why here I am taking only positive quantity, and here length of my x1 is 2. So here this means that the vector x1 is not normalized. I want to divide this length of x1 to the x1 so that the resultant x1 I got in the normalized form. Let's say here x1 dash equal to x1 divided by norm of x1. So this is equal to, here I want to, here this is equal to minus 1 by root 2, 0 by root 2 0 and 1 by root 2. Now we can check this x1 dash is normalized or not. Here now I want to find the length of x1 dash. Length of x1 dash equal to, now here minus 1 by root 2 square, that is 1 by 2. So this is 1 by 2 plus this is again 1 by 2. Here 1 square by root 2, that is 1 by 2, 1 by 2. This is equal to, here 2 by 2, this is equal to square root 1, this is equal to 1. Now here length of x1 dash is 1. So here initially x1 is my eigenvector corresponding to the eigenvalue lambda 1, corresponding to the eigenvalue lambda 1 equal to 1, lambda 2 equal to 2 and lambda 3 equal to 3. Here x1 is the eigenvector corresponding to eigenvalue lambda 1, but here length of x1 is not 1. So to make the length of x1 as 1, here I am dividing the x1 by length of x1. So this is my x1 dash, resultant eigenvector x1 corresponding to the eigenvalue lambda 1 equal to 1. Now we can check length of x1 dash is 1. So here this means that length of x1 dash is normalized eigenvector. In the same way you can check whether the length of x2 is 1, length of x3 is 1 or not. Now we can observe one thing, length of x2 is here 0 1 0, that is 1. No need to make changes in x2. Now we can observe one thing, in the similarly length of x3 is also root 2. So again we have to divide here by length of x3 dash. So this is my x1 dash here and x2 as it is, x2 dash equal to x2 as it is here, that is already 1. Now I want to find the length of x3. Here length of x3, again we can check, that is root 2 and write x3 dash as, here I want to write x3 dash as, here 1 by root 2 0, this is 1 by root 2 and here x2 is similarly means this is equal to, here 0 1 0. Now this is x1 dash, x2 dash and x3 dash. x1 dash is the eigenvector corresponding to lambda 1 which is normalized. x2 dash is the eigenvector corresponding to lambda 2 equal to 2 and x3 dash is the eigenvector corresponding to lambda 3 equal to 3. So these are the eigenvectors which are normalized. Now I want to form the model matrix P. So here model matrix P equal to, so here model matrix P equal to first column. So here I will write here. Now form model matrix P is, so here in my model matrix P, first column of my model matrix P is the first normalized eigenvector, that is this one. Here minus 1 by root 2 0 and 1 by root 2. Second column of my model matrix P is the second normalized eigenvector x2 dash which is corresponding to lambda 2 equal to 2. Therefore 0 1 0. The third column of my model matrix P is the eigenvector x3 dash which is corresponding to the eigenvalue lambda 3 equal to 3. So here 1 by root 2 0, this is 1 by root 2. Now in the question here x equal to py, here x equal to py is the orthogonal transformation. This means that this P is the orthogonal matrix. If P is the orthogonal matrix, therefore since P is orthogonal, then P into P transpose equal to I. Therefore this implies that P transpose equal to P inverse. So here therefore now form
D equal to P inverse AP. Here this is same as D equal to P transpose AP. Now first write this is my P matrix. So I want to find the transpose of this P. Therefore P transpose equal to, just transpose of this P is, here first row becomes first column 0. This is 1 by root 2. Here 0 1 0. Here 1 by root 2 0. This is 1 by root 2. This is my P transpose. Now D equal to, here D equal to P transpose AP. So here write this matrix minus 1 by root 2 0 1 by root 2 0 1 0 1 by root 2 0 1 by root 2. Now write the A matrix here. A is the given matrix 2 0 1 0 2 0 1 0 2, and here P matrix here D equal to P transpose AP. So here I will write this S3 dash over here. So here 1 by root 2 0 1 by root 2. Here this is equal to write P matrix as it is here, minus 1 by root 2 0 1 by root 2 0 1 0. Here 1 by root 2 0 1 by root 2. Now no need to calculate this matrix multiplication. D equal to, directly write the diagonal matrix with eigen values are as its diagonal entries 1 0 0 0 2 0 0 0 and 3. So this is your diagonal matrix D. So here till now we have find the diagonal matrix. First step, write the matrix notation. With this you will get the matrix A. Second step, find the eigenvector corresponding to the each eigenvalue. After that, find eigenvector corresponding to each eigenvalue. Then check the length of x1, eigenvector x1, x2, x3 is 1. If not 1, here length of x1 is not 1. That's why here I am dividing the length of x by length of x1 by x1, so that x1 dash becomes this, and we can check the length of x1 dash is 1, x2 dash is this, and x3 dash is 1, this one, and form the model matrix P having normalized eigenvector. This is my x1 dash, x2 dash, x3 dash. After that, since P is the orthogonal matrix, P into P transpose equal to I, therefore P transpose equal to P inverse. Then by diagonal matrix D equal to P trans inverse AP, that is same as P inverse is same as P transpose. D equal to P transpose AP. Here if this is the P matrix, so this is my P transpose. First column becomes first row becomes first column, second row becomes second column, third row becomes third column. So here I am writing D equal to P transpose A, and this is my P. So here the matrix multiplication of these three matrix becomes the diagonal matrix having diagonal entries are the eigenvalues of this given matrix A. So here now we have to use this by using this orthogonal transformation. So we have to convert this quadratic form into the normal form as. So here I will all of you written this. I don't have space. So here I will write here given information again. D equal to here 1 0 0 0 2 0 0 0, and this is 3. Now I want to convert this quadratic form into normal form by using this D and that orthogonal transformation x equal to py. So here in my working rule I said q equal to x transpose ax, use x equal to py orthogonal transformation in your quadratic form. So therefore this q becomes here using x equal to py in q equal to x transpose ax. Therefore q equal to y transpose dy. Here D is the diagonal matrix. This is equal to here. This is equal to y1, y2, y3, and this is given D matrix is 1 0 0 0 2 0 0 0. This is 3, and here y is here y1 y2 and this is y3. You can multiply these three matrices. This you will get y1 square plus 2 times y2 square plus 3 times y3 square. This is q equal to y1 square plus 2 times y2 square plus 3 times y3 square. This is the normal form or canonical form of my quadratic form q equal to this 2x1 square plus 2x2 square plus 2x3 square plus 2 times x1 x3. Now you can observe one thing. So here again I will write q equal to here y1 square plus 2 times y2 square plus 3 times y3 square. Now sometimes in the exam they will ask find the nature of the quadratic form, index of the quadratic form, rank of the quadratic form or signature of the quadratic form. So here what is meant by index? Here I will define the index. Here most of the time here index is defined by p. Index equal to number of positive term in the normal form, or either we can define by using this, or index equal to number of positive eigenvalue. So here you can observe one thing. This is my first eigenvalue, second eigenvalue and third eigenvalue. This is positive. Second eigenvalue is positive and third eigenvalue is also positive. So here number of positive eigenvalues are 3. So you can define index equal to p by using this, or and number of positive term in my normal form, that is 3. This is my index. So here rank of the quadratic form, here rank of the quadratic form of q equal to number of non-zero eigenvalue of the given matrix, or we can say number of non-zero eigenvalues of the given matrix, that is number of non-zero eigenvalues are 3. That is my rank of the quadratic form. So this is my index. So this is my rank of my quadratic form. Now define the signature. Signature equal to 2p minus r. Here 2 times this is 3 minus here r is 3. This is equal to 6 minus 3. This is equal to 3 is the signature of my quadratic form. Here maybe if they will ask, so this is my index, number of positive eigenvalue or number of positive term. Rank is the number of non-zero eigenvalue. So that is my rank, and signature equal to 2p minus r. Difference between positive and negative eigenvalue. That is here number of positive eigenvalues. 2p minus r is the signature. Here 2p, the value of p is 3. That is r is 3. So here 2 into 3 6 minus 3. That is 3. So that is the signature of my quadratic form. Here all the eigenvalues of my given quadratic form are positive. That's why this is the positive definite quadratic form. So here in this way you can solve the first rule, how to convert the given quadratic form into the normal form. First write the matrix notation of the quadratic form. Second step, find the eigenvalues of that matrix A. Third, corresponding to each eigenvalue, find the eigenvector. And fourth is build the model matrix P having normalized eigenvector x1, x2, x3. If length of x1, length of x2, length of x3 is not 1, so find the length and then divide the length of x1 to x1. So you will get x1 dash. X2, find the length of x2, divide that length of x2 to your given eigenvector x2. You will get x2 dash equal to x2 by length of x2. And in the same way, norm of x3, find the length of x3. If length of x3 is not 1, then divide x3 by norm of x3. You will get x3 dash. In this way, you will get x1 dash, x2 dash, x3 dash, which is normalized eigenvector. Then form the model matrix P having first column is the normalized eigenvector x1, second column is the normalized eigenvector x2, third column is the normalized eigenvector x3. After that, so use the orthogonal transformation. So after that, here write D equal to P transpose AP. So you will get the D is the diagonal matrix having diagonal entries and the eigenvalues of this matrix A and non-diagonal entries are 0. Then use this orthogonal transformation x equal to py in quadratic form x transpose ax. You will get the quadratic form, that is q equal to y transpose dy. So here y is the column vector y1, y2, y3. Therefore y transpose is the row vector y1, y2, y3. Write D matrix as it is. So here y. So just multiply these three matrices. You will get this form. So this is the normal form. And write here this is the first term of my normal form. Second term, third term. The normal form, some other, that is called square form. Here the index of the normal form is the number of positive term. So here first term positive, second term positive, third term positive. That's why index is 3. Rank is here number of non-zero eigenvalues. Number of non-zero eigenvalues are 3. That's why rank of the quadratic form is 3. And signature equal to the formula 2p minus r. 2 into p is 3 minus r is 3. Say 2 into 3, that is 6 minus 3. 3, that is my signature. And all the eigenvalues of the here nature is positive definite. Why? All the eigenvalues are positive. That's why nature of the quadratic form is positive. Thank you.